Okay, question 4. The diagram shows that the graph of fx, which is 1 over x plus 3 minus 1, and gx of x, the gradient of f intersects the x-axis at A and the y-axis at B. Okay, so there the graph intersects the x-axis at A and the y-axis at B. All right, the graph of f and g intersect at points C and D. First question, write down the equation of the asymptotes of f. Okay, so I can find my asymptotes over here. No? So the horizontal asymptote, I can think, what does x need to be to make whatever is under the fraction 0? So x would need to be -3. So the first one there, 4.1, for the x, that's equal to -3. And the y is easy to read. It's just this constant at the back, no? -1. Y is equal to -1. Okay, and that does make sense, no? If the y-axis is over here, -3 would be over there. That's the x-axis, -1 is over there. Okay, right, 4.2, determine the range of G. Determine the range of G. So Gx is the straight line, no? So it's going to continue going upwards, it's going to continue going downwards. So the range is y is an element of all real values. Okay, 4.3. Determine the domain of f. The domain of f. So when we speak of domain, we are referring to the x values the graph will cover. So we can see if we look at the graph, the arrow is pointing that way, so it will continue going all the way that way. It will continue going that way. Now, if we look at this portion of the graph, we can see that it will continue going that way. Now, but the only place where the graph won't cover, so at these points the graph is approaching this asymptote, but it will never touch it. So it will never touch at -3. So we can say the domain is x is an element of all real values, but x is not equal to -3. Okay, 4.4, 4.4.1. Okay, calculate the length of OB. Okay, let's look, where's OB? OB, and B is the y-intercept of the hyperbola. And to find the y-intercept, we always let x equal to 0. Okay, so we're going to work with the hyperbola equation. So y is equal to 1 over x plus 3 minus 1. So to find the y-intercept, we're going to let x equal 0. So y is equal to 1 over 0 plus 3 minus 1. That is a third minus 1. So that would be -2/3. So therefore, the distance of OB is equal to 2 over 3 units. Right, 4.4.2. They ask us calculate the length of OA. OA and A is a x-intercept, and their y is equal to 0. So for the x-intercept, we're going to let y equal 0. We're again going to work with the hyperbola's equation, since it's the hyperbola that's passing through the x-intercept there. So 0 is equal to 1 over x plus 3 minus 1. Take over the negative 1, becomes positive there. Cross multiply the x plus 3 over to that side, so that's going to be x plus 3 is equal to 1. Take over the 3 again, it's negative 2. So therefore, OA will equal to 2 units. Okay, right. Determine the coordinates of C and D. Determine the coordinates of C and D. So we can see C and D are points of intersection where the two graphs meet each other now. So it means at those points the two graphs are equal to each other. So we can put these two equations equal to each other and then solve for x and y. Okay, so we can say at C and D, if x is equal to gx, so we're going to equate those equations. 1 over x plus 3 minus 1 would be equal to a half x. Okay, so I can start by taking over the negative 1. So that's going to be a half x plus 1. And then I'm going to cross multiply the x plus 3. So that's going to be half x plus 1 times x plus 3. Oh, I could have done something to make it simple. I could have multiplied by 2. But anyway, okay, let's go with this. So this is going to be, if I multiply that with that, that's going to be half x squared. That times that is going to be 1.5 x. That times that is 1x, or just x. That times that is 3. I'm going to bring over that 1 as well. So that's going to be minus 1. Okay.